My AirPods is on. Okay. Mm-hmm. Not yet. Okay, it's loading. Yep, we're live. It's like around 30 seconds behind. That's okay. Okay, thank you. Thank you. Oh, hello. Let's see. We're live. Can people hear me? Just double checking. 6 people watching the stream, including me. Okay. Awesome. Thanks. We'll start in 5 minutes. How's everyone going? Curious, how many people from 6080? Hey, Gary. Good. Sanjana, Chinjan. Hey, guys. Okay, how many people have experience with JavaScript? Put in the chat. Hi, Rohan. I try to respond to the chat as soon as possible, but it's 30 seconds delay. Yeah, I can see that now. Somewhat experience. Okay, awesome. Basics. Yep, that's all you need. We'll go over some JavaScript as well. Order. Lend.js and yes, 680 game. Okay, so this workshop is kind of designed for people who just done 680. It's like perfectly, but other people will try to cater for everyone. Yeah, if you just did 680, you will recognize a lot of stuff and know what I'm talking about pretty much. Sup? Yes. Start in 4 minutes. Can someone take a photo? Gary, can you take a screenshot? I need an art photo. Hopefully it won't be this awkward when it starts, because I'll answer a question instead of try to interact with people when I'm 30 seconds ahead. Thanks, Gary. Never seen others using VS Code. So yeah, I'm trying to do everything in VS Code today. So I can't be bothered to have like 1,000 different apps open at the same time. Yeah. I have like 3 slides, that's it. And then we'll jump straight into coding, which is like everything in VS Code. So yeah. Okay. 17 people, wait for 2 more minutes. Feels like a tutorial. Always waiting for more people. Hey, Michael. Yeah, VS Code is cool. Hey, Evan, am I still overseas? Yeah. Okay, let's see. We're gonna get started soon. Glasses on. I'm not really short-sighted, just protect my eyes. Looking at computers all day. Okay, we'll get started then. So hey everyone, I'm Kaichi or Kai, and I'll be going through the introduction of TypeScript today. We scheduled this for 3 hours, but let's see how long it's going to take us. So let's go to the next slide. Why should you learn TypeScript? Apart from the everyone knows about the static typing, but apart from that, there's a lot of perks that you can get out of learning TypeScript. For example, you can understand types in JavaScript. JavaScript has types. It's dynamically typing, but for example, let's just make a variable. Let none is equal to 42, and we can hover over this number. This is actually TypeScript trying to interpret JavaScript with types. So we can, after learning TypeScript, you'll understand complex types. For example, commonly used in React. So I have a React app here, and this is the default React app, and I made a state. But if you hover over use state, what does it return? Like when people were first learning React hooks, they'll be like, what is this kind of stuff? Why is it like an array and then return 2 things? But if you hover over use state, you can see a lot of information about this typing, but it's very complex. And we'll try to slowly build up into this so that at the end of this workshop, you'll be able to understand a lot of complex types that you will see. And it will help you with not just, you don't have to write TypeScript. Like if you just develop in JavaScript or React or any other frameworks, it will help you with a lot of the typing information that you will likely to be using. Could you please zoom in a bit? Text is too small, the font is really small. Okay, let's try it if that works. Oh, that did work. I've never done that before. How is this? Hopefully it's better now. Yeah, it's much bigger now. So that's the first thing. And second thing is we can use newer JavaScript syntax. So EMAScript 2015 is ES6. That's the most commonly used one at the moment. But with TypeScript, you can actually use really like the latest JavaScript syntax that hasn't been implemented in any browsers yet. And then you can transpile to your TypeScript code to older JavaScript. And still bigger. Okay, one more. That's huge right now to me. I've never looked at text this big. Maybe that's why I need glasses. I probably don't need it anymore after I made it this big. Okay, cool. Thanks, Vivian. So yeah, we'll transpile all the JavaScript versions to all the JavaScript versions for browser compatibility. So in TypeScript, you can actually tell the compiler to transpile into a specific JavaScript version. Yeah. Okay, so and then we can catch typos. Everybody makes typos immediately when we write in code. Like this is really good actually. You probably won't notice. So actually, I don't need React anymore. So for example, I just want to console log this variable, but I typed it wrong, none instead of num, because n is right next to m, and we can't even tell the difference. It just says any. We'll get to that. We'll get to that soon, but we'll only find out that it's wrong when we run this bad.js. This is bad. Now we have a problem, right? But in TypeScript, if we just do the same thing, exact same code, but just in the TypeScript file, we're gonna immediately see that we cannot find this name, none. It's supposed to be none. So this is actually really good. And yeah, let's go back to our slide. Keep forgetting where my slides are. Okay, so and then it allows your IDE to give you better intelligence. So if you have an object and you're trying to find all the fields inside with TypeScript typing, that object, you'll be able to see it in VS Code, for example. And it will make your code more readable and better documented because every object has a type and you can see that immediately on your IDE. Yeah. Okay, next slide. Why should you use TypeScript? This is gonna have a lot of hate here, but just some comparisons. So JavaScript is not robust enough because it's a dynamic typing. And yeah, it's really easy to miss bugs until runtime. What that means is, like we demoed before, you won't be able to see this problem until you run it. And there's a lot of problems like, okay, what if I do const? You can't redeclare a variable, right? But you can't tell unless you run it. And then when we run it, we're gonna get problems again. So that's what it means by you can only see your errors when you with JavaScript in runtime. But in TypeScript, you can immediately know that you've made a mistake right in your IDE. Yeah. So this is the same error that we got in the terminal. So it's not even compile time. You'll see it in development time, which speeds up your your developing speed. So you don't have to wait till you run the code to find any errors. Yep. So that's that. And yeah, Python. Okay, this is interesting. So Python is similar to JavaScript, but Python actually has typing. However, it's very interesting that if I show you Python's typing, you'd be like, what is going on? So let's just make a function add A and B, okay? And return A plus B. So this is a very simple function. And if we print A, add 1 plus 2, that's going to give us 3, right? Everybody knows that. Yeah, so we got 3. But what if we do a string? So this is the problem with dynamic typing. And we're going to get 12. So what we can do is we can say that, okay, we want it to be int, right? But Python says, I don't care. I can still run it. I'm not going to stop you from doing that, from doing the wrong thing. And we can specify a return value. So if I hover over it, I know that, okay, int, yeah, that makes sense. But if I want to return an empty string, I don't care. I got an empty string here. So that's not really helping us. All it does is give us better documentation. But TypeScript can give us that, as well as telling us immediately as soon as we write this code. So yeah, let's forget about Python. So let's go back to our TypeScript code and have the same function. A and B return A plus B. Okay, cool. And yeah, we can do 1 plus 2 here. And that will be fine. And that's also fine. But as soon as we add in typing, it's not int, it's number. We'll get into the details of how this works. Immediately, I can see an error. And yeah, that's TypeScript. So when we get to classes, you'll see that it's actually really similar to Java, but Java is very verbose, and TypeScript has a lot of syntactic sugars to simplify the repeating code that you have to write in Java, similar to C++. Okay, that's all with the introduction, and we'll dive right into how to use TypeScript. Okay, cool. Let's go. All right, first of all, how can we use TypeScript? We need to install it, right? No, you don't. All you need to do, you need to have is VS Code. And as soon as you have VS Code, you can have all of those error checkings. But if you want to run this code instead of just writing it and looking at the errors, but you still want to use this code, right? So to run this code, you have to have Node, which I already have. And that's how I used to run JavaScript. And then with Node, you have npm, right? And with npm, you can do npm install TypeScript. And that will install it locally to your current directory, but you can do npm install TypeScript, npm -g install TypeScript. That will install it globally, which I'll show you. It will be in user local bin, and it will install TSC basically to your user local bin if you're on Linux or Mac. Yes, so more information here. Made it home in time. Hello, Oscar. Yes, so like, yeah, this is how you install. So more information in, I have more information here, and all of those are on GitHub. Okay, so, and then after that, you have TSC, which is the command. So after you install that, you have TSC, and that's kind of like GCC, like the compiler. And you can give the file name. So demo.ts, it's gonna compile it, technically transpile it into JavaScript. And now I have an error. I already know that. So let me just get rid of this code. And then compile it again. What's the benefit of using TypeScript over JavaScript? Wow, you missed the entire slides. Let me just quickly open that again. It's all in the slides. Those are the benefits. Yeah, JavaScript is dynamic and it's really easy to miss bugs, but TypeScript can catch bugs immediately. And yeah, that's what we got. And we can see our demo.js. It's changed to var instead of let because var is the older syntax that it's compatible with every single browser, right? So yeah, that's what's going on with installing TypeScript and how to compile it. So I've covered the compilation. And with -w, that's like watch mode. So every time you, Olga just joined, no worries. Our slides will be up on GitHub. And yeah, so with the -w, you can open watch mode, which is like React. When you save something, it immediately compiles. But we're not going to use that today because it won't require a lot of compilation because every time we make a mistake, we'll see that in the IDE. Okay, so now, okay, so far I've been running JavaScript on the console with Node. What if I wanted to be in the browser? Yes, you can do that. So let's have our index.html. So this is just the classic index.html, and I have a script tag that includes script.js. So all you have to do is write code in the same name, script.ts. Okay, so this is what I've got. I'm just console logging A, B using template string, which is a new syntax as well. And I'll just compile script.ts, and it will transpile to script.js, which you can use directly. It will be in the same directory, and you can use directly in the HTML. So if I open index.html, open our console, you'll be able to see A, B here. It's a bit small, but it's here. So yeah, that's working. That's just a very simple example of how you can integrate it into front ends when you have like plain old JavaScript and HTML. Of course, you can also use React TypeScript, which will probably be in a future workshop. Okay, so again, our template string is gone because it's a newer syntax, and now it's back to the older syntax that it's compatible with every browser. So yeah, that's very powerful. TypeScript can pretty much make your browser compatibility issues a lot simpler, which is a big issue in front end due to the dynamic nature of browsers. Okay, now let's have a revision on JavaScript's types. JavaScript has types. It's dynamically typed, but it has a lot of primitive types, which we'll cover now, and then we'll be using them in TypeScript. So yeah, JavaScript is dynamically typed language. And what that means is you can change the type of variable and add new properties to methods or methods to an object after it's been declared. So how about bad JS back? And what that means is that's wrong, so we'll get rid of that. Num, you can now make it a string. It used to be a number, but now it's a string. But we are in JavaScript, we're not in TypeScript, so it doesn't know. It still thinks it's a number, but whatever. That's just the IDE being not smart enough to know that. But because we are in JavaScript. But as soon as you move to TypeScript, that problem will be solved. And because of that, we can say that JavaScript is a dynamic language. So you can change your type on the same variable. That's pretty much it. And yeah, remember when we made a typo? It says it's any. So that's a type in TypeScript that basically makes it look like a JavaScript variable where you can change types. So you can think of every variable in JavaScript as of type any, and we'll cover any after this. And then we can see that we've already covered JavaScript's problems, a lot like redeclaring const variable, those kind of problems. But all of those will be fixed in TypeScript. So what are the JavaScript primitive types? There are 7, but those 5 are the most common ones. Number, if you didn't know before, number is actually double. So you store both integers and floating point numbers using like whatever the IEEE format or something in JavaScript. So we actually lose some precisions, but it is what it is. So it's a number type. It tries to simplify our lives, so we don't have int and double, but we have number. And we're in JavaScript, so that we can't do type annotation. Shrey said, strongly typed language systems, TypeScript allow us to build more robust and secure type code typically. Yes, that's correct. You don't really care about types. You're just writing. Yeah, so that's why TypeScript is kind of like the best of both worlds, both dynamically typed and strongly typed. Because TypeScript, if you just want to write something quickly, you can just do any or ignore TypeScript errors. And that's really helpful sometimes. Sometimes when you're writing Java, you just be like, why do I have to care about so many types? Like generics, especially. If you don't want 251, you've been through the errors that just like you don't understand. But in TypeScript, you can literally say ignore error, or you don't care. You can compile. It will still compile, which is pretty cool. Actually, I can show you that. So remember this, when we had a problem with adding a string, right? But when we compile it, we got an error, right? However, if you look at our JavaScript file, it doesn't care. It's still compiled, and when we can still run that code. And we got 12, which is what we expect from a JavaScript adding a string with a number. So that's how powerful TypeScript is. If you make type errors, it doesn't care. You can still compile it and run it. So it's very flexible. And yeah, that's that. Let's go back to our JavaScript primitives type. We have string, and that includes char. If it comes from C, string is not an array. It's a primitive type. Boolean, true and false. Now we have null and undefined. A lot of people are still not sure about what the differences are. Okay, Dope said, are there cases when building a web application in JavaScript is better suited than TypeScript? I'm not sure. I think a lot of companies nowadays all use TypeScript. And yeah, I don't know, using vanilla JavaScript to build a web app. I don't know about that. People coming from 6080 will know that vanilla JavaScript building web app is very painful and a lot of bugs. Yeah, very easy to have bugs. Okay, so the difference between null and undefined. So null is kind of like, so it's something that JavaScript or a lot of library uses to indicate that a function called fail, for example, that will return null. Okay. So something you try to get doesn't exist, but undefined is when you are accessing a field in an object doesn't exist, or like the element, accessing an element in an array out of range. That's actually legal in JavaScript, but you just get undefined, which is very, very easy to have bugs, have like those hidden bugs. And this is what we're trying to avoid in TypeScript. Okay. And so we can use null to indicate something that doesn't exist, but we'll try to avoid like those undefined behavior in TypeScript. Okay. TypeScript is a superset of JavaScript. Okay, you're one step ahead of me. Now we've done enough revision for JavaScript, so let's introduce TypeScript for the first time formally. So TypeScript is a superset of JavaScript. So what that means is every JavaScript code you write, you can just move it to the TypeScript file and it will just work, because JavaScript is essentially a subset of TypeScript. So JavaScript is TypeScript, but TypeScript, not every TypeScript is JavaScript, something like that. And yeah, TypeScript gets transpiled to vanilla JavaScript. We've covered that. and can be run on either browsers or Node.js. And you can specify the version of JavaScript that it transpiles to, which is really useful sometimes, but not as powerful as Babel. So don't use TypeScript just as a transpiler. And okay, so TypeScript has something very powerful called type inference. And you don't have to annotate types. So annotating types is by doing this. So that's telling this thing, okay, it's a number. But type inference is when you declare a variable, it already knows and you can't change it anymore. Okay, so that's an error because it already knows that it's a number. So string is not assignable to number. So remember in our JavaScript example, that's fine. This line is okay because JavaScript treats everything as kind of like any. So with type inference, it's so powerful that you can literally just write JavaScript in TypeScript in a TypeScript file and uses dynamic typing nature and alongside with type inference to have the half working typing ability, but TypeScript has a lot more to offer. So let's get into some TypeScript types. Okay, there's a lot of chat. Let me see. Using type more about robust. Yeah, thanks, Ray. Yeah, for example, if you want to get a game working quickly, like a hackathon. Oh yeah, if you want to get something to work really quickly, you can still write. I will still write JavaScript in a TypeScript file just to get the typing out of it. Like honestly, I would not write vanilla JavaScript to build web apps nowadays. Yeah. CC said if you're more familiar with vanilla JavaScript and you use case, it's super small. Yeah, or something really small. Yeah. Again, personally, I will still write that JavaScript in the TypeScript file just for the sake of it, you know. Anyway, okay, so with those all the basic types all the primitives that we cover in JavaScript can be used to annotate in TypeScript. Okay, so to annotate in TypeScript, we just do that. Okay, number, and we can make a boolean. Let's boolean true, and you can change boolean to false, but you cannot change boolean to a number. Fun fact, you can actually have a variable name that's the same as type, but not recommended. I can't think of a variable name right now, but you can see the color is different. So green kind of in VS Code in this theme is a type, and blue is like a variable. And you can see that that's the variable name. That's the name of the type. Okay. Yeah, Shrey, you're right. You're absolutely right. Okay, so let's keep going with other types. And with all of those primitive types, that's fine. Oh, I actually named it TF, means true and false. Okay, so I am creative when I was writing this markdown. So to be able to get this to work, all we need to do is make this any, and that means this can be any type. So it literally means it's a JavaScript. It feels like a JavaScript variable again, and that's any. With any, TypeScript will basically any function that you have with function parameters, TypeScript cannot infer function parameters. That's like one of the things that TypeScript cannot infer at all, because it doesn't know. You're not declaring a variable yolk. So this is only declared when you call the function, right? That's what function parameters are. So that's why it's saying every time you have a function, it's saying that parameter implicitly has any. So those are of type any because you never annotated. So in fact, that we don't need to annotate any variables because it already knows that by inferring it. But the most important part is you have to annotate all function parameters. That's the most important part. You have to annotate all function parameters to be able to enforce that this problem that we had before. So without that, we can do this once again. Okay. Yeah, so that's that. Any type. Let's keep going. The next basic type is arrays. So arrays in JavaScript or TypeScript is a list of a certain type. So like an array, let's say numbers, and if you give it a number and a bracket here, it's gonna know that this numbers is an array of numbers. It cannot have one and two in it. It must be of all the same type. That's what an array is, right? A list of all the things that of one type. So that's going to be a problem in TypeScript, and TypeScript knows that. So and TypeScript is smarter than that. If you do like push and you give it a string, no, that's going to be a problem as well. And same thing with any other like functions that takes in the specific type. Okay. Cool. I need to remember putting semicolons for good practices. So that's array. And after array, we'll have, let's look at function. Let me move this to the side. So function, we just covered function slightly. Now let's go into more details. So functions, let's have our add function back because I think I deleted it. Okay, yeah, so this is our function. And with type inference, if you hover over this add function, it already knows that number has been returned. It must return a number because a number plus a number, it can't return anything else. So if you really want, you can be implicit and write number. That's going to be the same thing. But without it, with type inference, we know that it's a number, which is really powerful. And like with Python, remember that Python problem we had without that, with or without that return type, it doesn't really enforce anything. So now that if we have a result, we know that it knows that it's a number. So that's really good, right? And if you want to write really old syntax, you can write function and it will be the same. Let's do subtract this time. And return a minus b. And that's the same thing. It will know that it's returning a number because a number minus a number is a number. Okay, so that's functions. Okay, now those are the basic types with TypeScript, right? But what if we want to have like an object? Let's just make an object. Object. Okay, we're gonna start to get into that state thingy in React. So let's have an object that has a state. Let's just make a number. No, sorry. Actually give it a number. And set state. So that's a function, right? So we can actually have functions in state. They're called methods like classes. So we'll just make it pretty trivial at the moment for now. Okay, so that's our object. And if you hover over this object with type inference, it knows that this object is of type. So that's a type. That type has a field called state, has a number, and another field, which is a method, has this type. It takes in 0 arguments and returns, it's a void function. So that's type inference. But if we want to have a function, let's have a React component, just pretending we are doing a React component. Component, and it takes in object. All right. And we'll just use that somehow. Let's console log object. And right now it's any. So same as any other functions, we have to say, okay, we want this to be type of this type. So we can actually call this function with this variable, right? So right now it's fine because it's any. You can call it with anything. You can call it with empty string. But we want to enforce that this object must, whatever pass into this function or this component must have two fields. One is state, and that's a number, and the set state, a function. So to do that, we introduce interfaces. Interface is something that describes an object. So we can have an interface. Let's use props. And so we can have a state number. Now I'm describing this interface, this object type. So set state. I'm going to use my example here. So because set state actually takes in a number. So a parameter number to void. So this is how you describe a type of a function. And now let's change this with a parameter new state. I just console log it for now. Okay, so that's our object. And as soon as we describe this with props, it knows that now I cannot pass anything other than an object look like that anymore. So that's an interface. It describes an object. And interface is really powerful. For example, you can make this read only. That's just one thing you can do. There's so many more things you can do with interface, and I'll get into that one by one. So once you make it read only, now object dot, see that IntelliSense? Because I described it with a interface, it knows what fields are there. And if I do state, if I change it, I cannot because it's read only. And that's just so powerful. So we can't change it, but we can console log it state, and we can call set state as well. We don't need to console log set state, and we can pass it. If we don't pass in anything, and it knows that it's a problem already, because yeah, with all the type inference and describing this, it knows, okay, it's gonna take in a, oh, right now it's any. So if I put in like string, it's a, nah, actually it's not good enough. So it has to be a number because of this props interface. That's read only. You cannot change a read only number, a read only field. And you can also have something like an optional field. What if sometimes I don't want to pass this in? And if I change that to question mark, that means it's optional. So if I don't have this, I can still pass that object in without it because now it's optional. So that's very powerful. If you can have an optional field, and because that's very common in JavaScript, like in web development as well. Like, what if you don't know what the return type is? Like, you could have this or you could not. You can make it optional. Okay, cool. Now, another thing with interface is you can actually declare interface with the same name and with a new field. Let's think of this React component. Let's have a render and it's Boolean. So whether we want to render something or not. Okay, does anyone want to guess what this does? Does it override it, or it's an error, or let me look at the chat. My font is familiar. I don't even know what font this is. Can we get any email that we participate in? I don't know what you're talking about. But yeah. Okay, any guesses? Oh, this already gave it away. But okay, so this essentially overloads, maybe not the best word, basically adds this field in here. So it's doing the same thing as both working, just depend on what you put in. Okay. So basically it's doing the same thing as putting it here. You might ask, why is that useful? It's useful when there's an interface coming from a third-party library, for example, that you import, and you don't know what it looks like, but you want to add your own field. So that's how you do it. But please don't do it if it's your own interface. If you just wrote that interface and you write it again, that's really bad practices. Just move that in here. Okay, just literally move that field in here. And you see that this is already giving an error because it's already been combined, even though I declare after it. So yeah, don't do it with your own interface, with the interface that you wrote, but you can, it's something that you can do if you really want with a third-party library that you import and they give you an interface that you want to add your own fields. So that's really useful in that certain scenario. Okay, so now that my OJ has a problem, I have to actually put a render and then say true or false in here. And that will fix this error. Okay, so that's called interface merging. Okay, so yeah, interfaces, declaration merging. And yeah. And with that set state, this is optional. Okay, that's it for interface. Now let's go into type alias. So type alias. Okay, we have a question here. Why does the new interface declaration add to the existing instead of overriding it? I don't know why, but that's a feature that you can utilize with third-party libraries. Like I said, I don't know why, but that's just a thing. It's a, you know, I don't know, what do you call it? What do we call it? Peculiarity. Yeah, a peculiarity in TypeScript. Interface can be extended by doing this. Okay. Yeah, type alias. And so type alias is literally just saying defining, it's like type def. So you can give an alias for a type. So look, this is a really good example, right? You can just change the boolean to bool because you think it's too long. And that's fine. You can do that. And now we have the same problem. If we look at our code from here, and instead of declaring it as, I'm just gonna call it bool this time, but let's annotate it with bool. Now this is bool, but it's just boolean. It knows that. It already knows that because it's a type alias. It's an alias. So yeah, that's one thing you can do with type alias. And remember that really long thing here. Yeah, that's our function type. If you think it's too long, like I said here, if you think that's too long, you can type aliases. So let's just literally copy that and put it into type alias this time. Set state equals to that. Oops, I copied it twice. Yeah. So now here we can just use set state. Okay, cool. Yeah. See, it's type alias. So this thing is an alias of this entire type definition, which contains the type of all the arguments and the return type. Okay, cool. So that's type alias. But apart from aliasing stuff, there's a lot of things we can do with type alias. So type, let's make a new type. Now introduce something called state. Sorry, tuple. I was reading the wrong thing. So this is now very close to what you would have seen in React use state, right? So if we go back to here, so let's look at the return type. So now you understand, okay, so this looks like a function type, right? Remember we have arguments that we just saw and a return type. So that's the return type after colon. And that return type, it's a tuple. with the first thing as a string, and the second thing is this huge thing. So that's a good start. Now we're starting to understand what that type is. So yeah, let's just mimic that set state. Use our own function. Yeah, so we define our own function and put that in a tuple. So now this is a type alias of a tuple. Okay. Now if we try to do something like, I'm just gonna write use state of this type. And if you're trying to do something funny like 1 and 2, that's not gonna work because it's enforcing it, the type. So number, which is 2, the type of 2, is not assignable to type of this. And of course you can, it's a tuple, but you can also have more than one thing. So it's kind of like an array already. It's not really a tuple, but they call it a tuple. So number, I don't know, string, boolean. Yeah, now you can have const tuple of type tuple. And then if you declare, you have to have 3 things now. So this is enforcing the number of things as well. So you have to have an array of 3 things. So if you only have 2, it's already telling you that source has 2 elements, but target requires 3. So yeah, we need 1 more, and that needs to be a boolean, right? And if we do something like it, because right now it's a boolean, right? So if we try to push another thing, I've never tried that before. It's not giving me an error. It's not smart enough in this case. But if you try to do like, all right, let's make it let. If you try to reassign it to something with only 1 thing in it, that's not gonna work. Yeah, same error, right? And every type has to be the same type. So if you have 2 number and a boolean, instead of the second one, instead of a string, that's gonna yell at you again. Why is a tuple no array? Yeah. I have no idea why they call it a tuple, but I don't know. Is it immutable? Let's try if it's immutable. I don't think it is. So let's assign the first one to a string. Let's make that a string. So that's fine now. And this one is, yeah, so it's not immutable. You can actually change it, but like I said, the typing is being enforced here. So the 0 element is a number. You cannot assign a string to it. But if you change it as a number, it will work. Yeah, it's mutable. So it's different from a Python tuple. But every type in that list, let's call it a list, is enforced. Yeah, Oscar gave a really good explanation. An array is like a set of values, like 1, 2, 3, but tuple is a definition of set of types. Yeah, so this is a definition of set of types. They call it tuple, just live with it. I don't know. Okay, so after tuple, we have intersection. Okay, we're gonna use our props example. Okay, let's grab that. I'll just copy this, and then have more props. I copied it. Let me get rid of this part. Okay, cool. So we have our props, and this time render is optional. This one is read only. I'm just trying to use everything we can, and then we have a set state. And let's add more states. So we have a more state, and the original state. What if we AND them? So that's an %. What if we combine them? So what that's gonna do is that's gonna combine all of the fields. Okay. It's just going to combine all of the fields. That's all it does. That's all it's doing. It's intersection of. So if you think about this intersection of 2 objects that has different fields, what's the intersection of that? Like, what's something that can be both? Right? It must be an object with all of the fields. So that's pretty much, that's why I call it more props. So it's like a combination of that and that. Okay. So yeah, so on my notes here, yeah, I can declare a a variable with this type. That's still optional. I can have it. I don't have to have it. If I have it, it's fine. It's not going to yell at me. See, it has state here, more state here. Oops. And set state here. And that's optional. So it must have all of them. So if you're missing one, for example, that, it's going to say no. So yeah, pretty much it's a combination of both. So yeah, we'll get to union. It's union. Yeah, we'll get to union and we'll get to the difference, because it might be confusing with objects, but underneath intersection is something that can be both, and union is something that can be either one of them, right? So if you think about objects, how can something be both this object and this object? Must be an object that has both of those fields, right? Okay, but with intersection, there's something that you might run into, which is interesting. So what if you do type, let's just call it none because it doesn't have anything in it. What that means is number and string. What if you put in, what if you take two things, if you take two things that has no intersection? So if you hover over this, it's going to tell you never. There's nothing intersecting between number and string. So this type never is actually a type in TypeScript. And what that never allows you to do or not allow you to do is assign anything. So you can't. So if you have a variable of type never, right? If you have this as never, you can't assign it to anything. Like, nope, that's wrong. Nope, can't do that. Nope, can't do that. You can't do anything really. So when you use intersection, have to be careful. You might have no intersection, and that's normal, right? Two sets have no intersection. That's fine. So be careful. Just be careful with intersection. And now union. With union, let's use those two examples, right? With union, this time instead of that, I'm gonna call it common and union. So if you think about it, what object can be either that or that? It must be an object that has the common field in both of them. So now let's make an object and test it. Same thing as here, const common props of type common props. Okay, so what can we put in here? Right now it's an empty, and so it already tells you it's missing state and more state. So all we need is state and more state. Why? Because okay, let's just start with state. And what type is that? Any type of state. Oh wait, it was number. Never mind. Oh wait, I keep forgetting that I'm writing an object, not a type, not an interface. Okay, so we have state here. And what else do we need? So let's go here. Union. Yeah, this is what I was trying to do. Why is it asking for more stuff? Okay, I actually put in the function. So let's put that in the function because there's something that we need to demonstrate with union. Okay, cool. Okay, so this is the function. That we're gonna cover, that we're gonna try to do. Okay, cool. Yeah, so we have a function, use props, and we want to use this. We want to take an argument of this type, union type, and we want to use those fields, right? So common props. Now, if I do a dot, the only thing I can see is state, because that's the common field, right? Oscar asked, is the type inference good enough that you can make an object that conforms to the requirements of an interface but don't declare? Yes, I think it is. Yeah, if you just have a literal object, yeah, type inference will give you that type, but you have to copy the type and put it somewhere else. You want to use that. That's why we have an interface. So it's kind of like to reduce repetition. So you don't have to write this over and over again. But yeah, I'll get into alias type, anonymous types later. Okay, now state is the only thing we can see. If you try to do something set state, it's gonna say it doesn't exist on both because it only exists on one of them. So this union thing introduces something called narrowing. So we need to narrow the type down. Okay, how do we do that? There's a operator called in TypeScript that you can just say set state in common props, and if that's true, I set state common props set state. Why is this yelling at me? An argument for, oh, I need to provide. So now it actually exists, but I just need to pass an argument. See how smart that is? It immediately tells you if you made mistakes, and we all make mistakes. And that's super useful, right? Why and when unions are useful and in sections? Yeah, you'll see very soon. I have examples. So yeah, so set state 0. So now we can call set state, but inside this if statement, TypeScript is smart enough to know that inside this statement, this if statement, it's props. It's not more state, because common props is a union, so it can be either, right? But inside this statement, it can only be one because that field is only in props. And then we can do like else. Now inside else, if I do a dot, now we have two things. And where are they from? They're from more state. Because if you hover over this, it tells you it's more state. So this is how we narrow down which type in a union is. Because we introduced this union, we now need to deal with which union it is. Okay, so why is it useful? I have an example here. So let's just say I have a function that takes in an input. And it can be either here. So type this data field, it can be either a number or a string. Okay, so if you see the number and string with a union, that's fine. That's not never. It's only never when it's an intersection, because it can either be a number and a string. Yeah, so we can have data is a number, or data can be a string, but data can't be a boolean or anything else. Yeah, so that's a union. And with that, so let's just say we have a function. So we need to do something with it, transform this input, and it takes in data of type data. Okay, cool. So data is either a number or a string, right? And we want to say if it's a string, how do we do that? We can use type of operator, the type of operator in JavaScript. This will tell TypeScript that triple equal. This will tell TypeScript that data is now a string. So now you can see I have all the string methods, right? Let's just return. So it's a pretty trivial function. And inside I can do else if, or I can just do else. Or if you want to be more explicit, now it has to be numbered. And I can return math or round or something, because it takes in, if you hover around, it takes a number, right? So if you try to do this here, it won't work because it's expecting a string here. So yeah, that's narrowing down with type of and in. So that's two ways to narrow a union down. Yeah, so that's union and intersection. So now let's look at what can we do with it. So yeah, union and intersections. What can we do with it? Well, the fact that let's go over this. The fact that union and intersection doesn't have to take in a type. It can be literal. It can be a literal string or anything. For example, like Boolean. What's Boolean really? Boolean is literally true or false. That's Boolean. That's literally it. You can say true or false. And yeah, we can't alias Boolean because it's already been alias. Yeah, so it's literally true and false, true or false. That's using a union type. And we can make our own. So I have some example here, like bits. What's bit? It can either be 0 or 1. And now if you have a function that only operates on that, you know that what it passes in has to be 0 or 1. Okay. And I have other examples here. Let's have hex. That's hexadecimal. So 0 to F. And that's a bunch of union stuff, right? And oops. And if we can actually operate, we can actually have like more complex data structures or data types actually. Like if we combine them, we can have something like bit or hex. What's that going to give us? That's just going to give us hex because that includes 1 and 0. And what do we do if we with AND it? It's just gonna get 0 1. And sometimes this is not really useful, but this is useful, right? Like if we have a function and we want to enforce what that function takes in as a parameter, we can give it a type definition like this. So that if that function, let's say something like convert hex from and take in a hexadecimal, as long as we declare this, let's just return whatever for now. I keep forgetting to write equal with this syntax. Right? And now if I call this function with anything but 0 to F, like -1, it's gonna yell at me. But if I call it with 1, that's fine. If I call it with F, that's fine. Call it with J, no, that's not okay. So that's already enforcing what's being passed into this function so it doesn't break if you actually want to use this hex number. So yeah, that's something very useful. Okay, after that, we've covered all the basic type aliases. But you might notice I can actually do something like, let's just go all the way here. Okay, type. I can actually describe an object with something like name is a string. Yeah, something like that. And isn't that the same as an interface? I'm just gonna call it interface. What's the difference? Well, yeah, you can do both, but what's the difference? There is no difference in this example, right? But what is the difference between an interface and a type alias? Well, there are a lot of differences actually. For example, with interfaces, you can't do something like interface like a union and whatever, right? Yeah, that doesn't work. So that's only a type alias thing. So I have some notes here. I have to open my markdown again. So I've listed all the differences. Not all, but some of the differences, some of the common differences here. So with interfaces, you can do declaration merging, but with types, you can't. So if you declare type A is equal to a number, and you try to declare it again, that's just stupid, right? It doesn't work. But if you change that to interface, it will work without the equal, right? That's just going to give you a type A that has both A and B in it. So that's something that type cannot do, type alias cannot do. And interfaces, back to, so now we're going to OOP. Interfaces can extend and implement like classes and interfaces. So that's another thing to extend or to build on your object other than doing this stupid stuff, merging. So what we can do is, let's go, where's our interface example? Okay, let's just use props. Okay. So we have our props here. I don't want any errors in my code. Okay. Yeah, so we can actually have a new interface that extends props. And we can give it more fields, like what more props? String, sure. And now if we have a variable more, I'm out of variable names. So this has to have 1, 2, 3 fields and an optional one, because we kind of combine them. So this is the same thing as doing it's not the same thing, but it can achieve what declaration merging can achieve, which is by adding more fields. So now I must have more props as a string. Still not good enough. I need state 0, still not good enough. Set state. Let's just give it a dummy function. I can't be bothered to write a function. So now it's happy, right? Now it's happy. So that's something you can do with interfaces, but you can't just type more props extends. It just doesn't, this thing, it doesn't even get highlighted. It doesn't work. Yeah, so that's something you can do with interfaces. But type aliases, we can do tuple, intersection, union, all the things we covered that interface can't do. So that's the difference. But generally, if you want to describe a object, like that object, use interface, don't use type. That's just a convention, because it's kind of like, think about it like classes and objects. So interfaces describe a class, right? That's the definition of interface in OOP. So yeah, conventions use interfaces, don't use type. Now we have generics, and oh yeah, type alias are anonymous first, and then we go into generics, which you will see very soon. Anonymous types. So you don't have to write type alias every time. You can just use the literal type like that, right? Yeah, for example, you can have a function that takes in the input and just say, I want this input to be number or string, or even I want it to be an array. And that's fine. That's just a anonymous type. So it doesn't have a name. So you can't really reuse this. But if you're only using this type once, like for this argument in a function, then an anonymous type is probably very useful for you. Yeah, so now like input is an array. It's an array of either number or string. So input, it has all the array methods here. Yeah, that's what I was telling you about better intelligence in your IDE, because it knows it's an array, so it gives you all the array methods like push, map. So yeah, that's anonymous type, and it also works with objects like yeah, you can. I think Oscar's question, yeah, if you can just describe this. Okay, if you get rid of this type with type inference, it tells you that that's the type. So if you just copy this and put it here, that's the type of the object that you're taking in. And now input has 3 fields. It knows that it has 3 fields because you just described the type of this input, this argument, right? But that looks ugly, right? That's why we're using interfaces and we're repeating ourselves. So yeah, that's why we use interfaces. And yeah, we can change that to, was it more props? Yeah, so we change that to, and now it's the same thing. It has those fields, right? Yeah, that's right. Yeah, it has 4 fields, more props, 1, 2, 3, and an optional one. Yeah, and that's optional. Okay, with optional, there's something to be careful of. Because it's optional, it might be undefined. If we, for example, like, okay, let's do this. Console log input.render. That's optional, right? So it doesn't, you don't have to pass it in. You can call it with, oh, I have an object here. I can call it with object. Let's just call it with more. That's happy. And it doesn't have render because it's optional. It's gonna give you undefined. So now, oh, we haven't compiled this for ages. So let's compile our demo and run our demo.js. Yeah, it's gonna give us undefined. So that's something to be careful of if you have an optional field. And that's what we're trying to avoid, right? In TypeScript, like it might happen. Okay, cool. That's anonymous type. Generics. This is something that really makes our typing useful and flexible. Okay, back to our set state example. So our set state, it's always taking a number or a string. We can't change it, right? Okay, where is our set state? Search set state here. Not that one. Here. It always takes a number. We can't just be like taking whatever we initialize it to be, which is what React useState does, right? So remember, this is a number, it's a string, sorry. And if I change my initial value to 0, and if I hover this again, it becomes a number. That's generics. It allows you to have types that change based on your input, based on user input. Not user input, based on what the programmer wants, right? So that's very useful. So how does generic works? Now we can redefine this. So let's redefine this. See, I can't redefine this, right? Because it's, yeah. Okay, let's make this capital. Okay, that works. Yeah, so it's a case, so types are case insensitive. So instead of doing number, if we just do t, which is like a variable that indicates what type it can be. Now we have to define this variable. So this is how you define it. That's generics. So this function type can take in a type as the type of this function. So how does that work? Okay, let's finish up our interface from before, that improvement of our interface. So interface can also have generic. Yeah, state now it's not number anymore, it's t. And set state, we can now use our function. Sorry, our type alias with t. So now this interface, we can use this interface. So first of all, let's make a function of this type first. I'm looking at here. So yeah, set state. So to make a function that's a generic function, we put the generic here at the start. And then we have a parameter. The parameter new state. Now that's like defining what this t is like. This is defining what this is. So if you see like angle bracket, just think of it as like defining what this generic type is. So now from here, I know this is what this is. That's what it means. And then, okay, so let's console log our new state. So this function is very trivial. It takes in an argument and console log in. Okay, right? So now with this function, I can have our object. So this is the object that of type state. Now it's time to give it a type. So it can be number, it can be string, it can be anything. Let's just use number. Now with this type given, this object must have those two fields, and that must be a number based on this. And so is the function. It must take in a number. So state must be a number, and use state. So this set state field of this type, and that function is what we just got. So that's the function that we just wrote, right? Or I can just move this in here. Let's make it less confusing. Cool. So this is a generic function. It takes in the argument and it console log it. That's just a pretty trivial function. And now use state. Now that's a object of this type. So it has two things. Set state. You see that? It says number here. So that's based on what this object is declared as. So if I change the string, and that's broken again, so I need to change the string, right? And here, set state bracket. Now it takes in the string. So if I'm not putting number, it's not going to work. So it's red. And yeah, it says number is not assignable to parameter of type string. So that needs to be a string. So yeah, generics is very powerful, or it can be confusing. And if you've done 2511, generics is covered in 2511, object-oriented programming, because Java uses a lot of generics, and it's the same concept in TypeScript. Okay, cool. So that's generics. Yeah, generics is a lot to take in, but we have more. The next one is a big topic, classes. So I'm just make a new file. And we're gonna together construct an example of a class. And I'm thinking of a linked list, because everyone knows a linked list if you've done 151. Okay. Okay, so linked list. It has a value and it has a next pointer, right? That's what a linked list is. And with TypeScript, you can have a very similar class as you would in Java. So JavaScript classes are very, very bad. It doesn't have modifiers. Everything is public. It doesn't have encapsulation at all. But in TypeScript, now we have keywords like private, which is the same as Java. It means you can only access in the class itself, and you can have protected. Let's just use protected for now, just for the sake of it. Okay, so we have a value. Let's use number for now. And next, so it will point to itself, right? It's a linked list, so we can give so a class is also a type. So it's very similar to Java. And okay, we're gonna have a constructor. So a constructor, when we first declare, or when we first instantiate this class, we're gonna give it a value. And constructor is kind of like a method, right? So it takes in a parameter and it does stuff. So let's make it 4 spaces, much better. Okay, so now we just do okay, this dot value equals value, and then this dot next, because we are initializing it, so we're doing it null. We're making it null. So the first time you make a linked list, it will just have one node. Okay, cool. Let's have some methods. So methods, we For example, what can we do? We can add a value, right? And yeah, what that's gonna do is probably let's call it append. So it's more clear that we are adding it to the end of the linked list. Okay, classic stuff. Let cur is equal to let cur is equal to this. So you see that this is referring to itself. So what's the type of itself? It's a linked list. So it's this type. While cur dot next. And then cur equals to cur dot next. Okay, so now we run into some typing issues. So we're just looping through it and then until we get to the end. That's what we're trying to do here. So, and then let's finish that so it makes more sense. So cur dot next. So when we get to the end, it's meaning that that's the end of it, right? So all we gotta do is make a new one. So new linked list value. I need a previous to actually attach to it. Okay, we'll deal with the details later. So type linked list is not assignable to type this. So basically, this type inference is look at the type inference. It's saying it's this, but we are making it linked list. We're making it that, but TypeScript is not smart enough to know that. So let's just make it super clear. Now it knows that okay, this is linked list. It's of type linked list, right? Yeah, and then let's just print it out. We have a method display and then just loop through it and then print it out. So we need the same here. And just print this thing. Console log cur.value. Okay, so to use this, we can use a new keyword like this. So it's similar to this. And we just make a new variable. Let's call it linked list. Yep, and let's start with 0. And then we can append to it like dot append 1. So now if I do linked list display, it should give me 0, 1 if I implement my linked list properly. I haven't done 151. Okay, so compile it, TSC class. No TSC, no class. I print 0. Let's append another one just to debug this thing. Oops. Compile. 0, 1. Okay, we're not adding. Oh, right. So that I'm not printing the last value. Yeah, that's right. I'm not printing the last value. So while I might just put a console log at the end here. I'm lazy. Okay, there we go. Okay, so this is a simple class that looks a lot like Java. But TypeScript has a lot of syntax sugar that we are going to use right now to make this a lot shorter. So first of all, there's something really cool. If you're doing private value num and something, and then you're going to initialize it here, TypeScript says, why don't we just write private here and get rid of 2 lines? So that's literally the equivalent of those 2 lines, because it's this operation. It's so common that it's might as well just put a syntactic sugar to simplify it. So that's literally saying I need a private value of type number in the class as a class member, and when I do a constructor, I pass it in and I assign it to it, right? And it's the same thing. So if I do linked list dot see that it doesn't even give me prompt, so I can't just access next or access value because they are private or protected. So if you don't say anything, it's public, so you can just say public. if you don't say anything, it's default to public. So if I do private here, I can't do display anymore. So it's different from Java. Java is if you don't say anything, it's default to default. Yeah, it has a fourth type of access modifier called default in Java, but TypeScript just detected public, private, and if you don't write anything, it's public. So I think that's very much that makes more sense than Java, right? I don't know, personal opinion. It makes more sense. If you don't write anything, it's public, and if you make it private, you can only access here, access within the class. If you make it protected, you can access in any subclass of that class. Yeah, so that's one thing, and we can also just do that. Why don't we need a constructor, but we don't actually need to have anything in the constructor, right? Yeah, we can just initialize it right here on the fly. And that just made it 3 lines shorter. And let's add in generics, shall we? So instead of every time it can only do numbers, I can't do string. But what if I want it to be like the use state? Whatever I give it to initialize it, I want the state to be that. That's why that's where generic comes in. So now I'm just going to change all that to generic and change number to T. That's all I need to do. And now this error is gone because I initialize it as a string. Now those two, I can't add numbers anymore. I have to add string. Yeah, let's make it more obvious. Because I can't, if I print it out, it can't tell. ABC. So now if I compile and display, it's going to display A, B, and C. See? Generics makes our class a lot more flexible. Yeah. Yeah, that's classes. How long did that take? Oh, they only took me like 10 minutes, pretty quickly. We finished that pretty quickly. So last thing, I think that's most of the content that I wanted to cover. And if I go all the way down to my README, I have all the code here and it will be on GitHub. Yeah, so TypeScript also supports a lot of OOP concepts. You can make an abstract class that I'm not going to cover. Yeah, inheritance, class can extend on a class. Class can implement interfaces, which is the same in Java. Now, here it comes. Interface can extend an interface. We've covered that. But an interface can extend a class. Have you seen that before? I don't know, but it's there. I've never used it. But yeah, if you really want OOP, you can do it with TypeScript, and it's very useful. Last of all, this is the recommended resources. And I basically looked at this doc. It covers a lot of details and pretty useful. So yeah, that's what I've been reading about. And if you want to learn more about TypeScript, look at the TypeScript handbook. Yeah. Any questions from anyone? We implemented a linked list, and we covered most of the we covered generics, none of the types, interfaces, unions, intersection, and all the function array and basic types. Yeah. Do you guys have any questions? Well, I just want to say, if you get nothing out of today's workshop, you can still start flexing your TypeScript knowledge by writing vanilla JavaScript in a TypeScript file. Try it. Trust me, it's fun. If you really don't want to write any type annotations, just write vanilla JavaScript in a TypeScript file. It will make your debugging even easier than writing JavaScript in a JavaScript file, which you know what I mean. yeah, TypeScript is really powerful and I really like it. If there's no more questions, that's pretty much the end of the workshop. 1.5 hours. Okay, not bad. Could have added more content, but I don't want to overload people with it. Okay, thanks everyone for coming. Okay, really appreciate it. I'll hang around for a bit because I know the stream is 30 seconds behind. Yeah. I just realized I forgot to record on Zoom, but it's on YouTube. That's fine. Oh well. No worries, Oscar. Yeah, I'll hang around a little bit if you guys want to chat or yeah, go and do some cool stuff with TypeScript. Might have a React TypeScript workshop later on. Yeah, we can integrate straight into React TypeScript. So yeah, this is actually a React TypeScript file. And now you understand this. So if I go into the type definition, like, so yeah, it's a function. And then, okay, let's look at what dispatch is. Yeah, it's a type alias. Now you understand. And it's a generic. Oh, so dispatch is literally a generic function that takes a value. Return void, that's what useState is, right? And now you know exactly what type of those two things are. And React TypeScript, let's go. Next workshop idea. Class optional. Oh, why you deleted that? Okay, I love optional. I use that in Java. It's pretty cool. Rip, I missed it all. That's okay, sorry. To record it on YouTube. You can find it straight after this stream. Yeah, I'll probably look into a React TypeScript workshop. So many types here. Dispatch without action. Set state action, generic takes in the number. Ooh, overloading. Yeah, I didn't cover that. Is there no way to assign a value of undefined for some generic type T? So, class optional T private. Okay, let's look at that. Since we have nothing to do right now. Optional T. Let's make a new one. Yeah, so we have value and then constructor, right? Constructor, value. Oh, optional. Okay. I see where you're going. This fails compile. Okay, let's see. So making this value optional, and it can either be that or, but what's the default value? Shouldn't it be default value? Let's try to compile this. What did I call it? Optional. Oh, why did the fail to compile for you? Okay, let's try to use it. Const optional. So if I don't provide anything, let's just console log this thing. So it's optional. I don't provide anything, and oh, it's just undefined. Yeah, it's undefined. But if I provide 1, hopefully now it's 1. So yeah, it's value 1. Yeah, works for me, Oscar. So yeah, you can have an optional parameter for a function. I think it's better to make this like let's make it null. So instead of having undefined, which is what we're trying to avoid in TypeScript, we actually want it to be explicit. We want it explicitly to be null instead of just a random undefined. It's still undefined. Huh. It's never used. Oh yeah, I've never used it, but why is it still undefined? So if I don't pass in anything, if I don't pass in anything, it's gonna be value. Oh, okay, gotcha. So we can do like if value. If it's not value, it's gonna be null. Yeah, it's null is null. Yeah, so this is so if that's why I was telling you about to be careful with optional things. If it's optional, it could be undefined, which is what we're trying to avoid. And yeah, so this ensures that only assign it if it's not undefined or any non or we can be more explicit. If it's not equal to undefined, then we do it. Otherwise, we don't do it. Otherwise, it's gonna be null. Yeah. Oh, I see. It's because I typed. Okay. Sure. I don't understand what you're saying here, Oscar. But yeah. Okay. Cool. So I hope that answers your question, though. Anything else people want to talk about? Just so you know, I'm looking at the chat on my phone here. That's why it's like I have to look at it like this. Yeah, anything else, people? Yeah, compile's fine. Yeah. Awesome. TS node. Okay. I'll hang out here for a bit more, for a little bit longer. I really want to get some water because my throat is really dry right now after all the talking. I'm just pull out my slides here for fun because it's beautiful. Thanks, creative. All right. If there's no more questions or no more comments, I might just go and have a break. Yeah. Okay. Thank you, everyone. Sanjana, you still there? Do you want to end the stream? And thanks, Sanjana. She's helping me streaming to YouTube from Zoom.